Goldgate Engineering Institute.
Okay, good morning. You're asking me a question in relation to wind exposure factors in the design of building structures. So your question is, how did I obtain the wind exposure factor in the design of building structures? That's a fantastic question, and I'll explain the application of wind exposure factor very succinctly using an illustration. Now, for closed buildings, when you evaluate the wind pressures are obtained at different elevations, as we have said in previous illustrations and previous videos, that the wind pressures obtained in every direction is a function of the crosswind dimension and the elevation. Okay, so it's a function of the crosswind dimension and the depth. Okay, the projected depth in which the wind approaches. So you get the external wind pressure coefficient, you get the internal wind pressure coefficient, and they get the resultant wind pressure, and then you obtain the equivalent loads affecting each bay. Okay, now to determine the exposure coefficient is used to determine the equivalent wind loads at the joints for a wind blockage area that has openings. I repeat again, the exposure coefficient is used to evaluate the total or the equivalent wind loads at the tributary joints for a wind blockage area that has openings. For example, if you look at this building structure, this is the north side, that's the south side, that's the east side, that's the west side. If you look at the south side, now there are how many bays? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 bays. Okay, now on the south side we can see that this region, you have a workshop shelter which is more elevated than these other regions. So you have is of a higher elevation or you have 2 levels as opposed to this other location. But I'm going to use one location as a typical example. When you calculate your wind pressure after using the expressions contained in 1991-14, obtain your fundamental basic wind speed, right? Your basic wind speed, which is a function of the corresponding coefficients, right? And then you get your wind pressures. Now, to determine the wind loads on closed areas, what STAAD will do, if you're to use STAAD to determine your wind pressure. Now I'm using as an example. So if you use STAAD to generate your wind pressure, you will generate your wind pressure, okay, after specifying the code specific parameters. Now you will need to tell STAAD which of the bays, or rather the exposure coefficient on each of the bays, if the coefficient is different from 1. Okay. Now what happens is that the wind pressure will be calculated, and the resultant force, if for example this is a windage area that has no opening, so if for example you have no window, the total wind force will act on the windage area. So let me do a little illustration. Right, so if you have, that's a bay, this is a bay, and then you have other bays continuing. Let me draw a continuous line. You have another bay there. So this is your bay, right? And now you have the total wind pressure. So the total wind pressure times the windage area will give the total wind force. That total wind force will be acting at the centroid of the windage area. Okay? It will act at the centroid of the windage area. So this is the center of the windage area. So the equivalent force that will act on the joint, if the total area is enclosed and there is no opening whatsoever, right? The total force divided by 4 will give you the joint loads at these joints. Okay? The total force divided by, so total force, right, is the wind pressure then times the windage area. So equivalent static wind pressure area will give total force. That divided by 4 will give you the loading on the joints. for closed windage area, for closed structures. Okay, for open structures, the wind load will be applied on the stanchions, okay, as distributed loads. Then for flexible structures, you have to calculate the external and internal wind pressure coefficient as well too, and then you get the corresponding windage zones. You have zone A, B, C, D, E, and so on, defined by the code and so on. But I want to specifically explain how the exposure coefficient is evaluated. Now, assuming that this, which is more practicable in many buildings, assuming that this building has windows. Okay, so the same building I'm referring to now. Okay, so this is this bay under consideration. So that's the continue to the next bay and so on. Now, if there's a window here, right? So you have a window here. What will happen? You need to tell STAAD the proportion of the tributary area that will be impacted by the opening. So remember, this is the exposure area. Remember. Now, if there's a window here, what will happen is that you have to tell STAAD the exposure coefficient of this zone. Previously, the exposure coefficient will be 1, so it will just, the total force or the force on each joint will be the wind pressure times the total area, and then that divided by 4, because this area, right, is 1/4 of this area. Now, but if there is an opening here, what you will do is you have to tell STAAD what the exposure coefficient is. Exposure. So the exposure coefficient is the ratio of this area, that's the closed area, to the total area. So that's this area you're seeing here, this area excluding the opening, the ratio of this area excluding the opening to the total area of this structure. That will give you the exposure coefficient. So on this analysis, or rather in this analysis that was done, this is the structure 1, 2, 3, 4, 5, 6, 7, 8. So 8 bays, right? Now, if you look here carefully, you have 8 bays. Now, let's look at what's happening here. Now, this is 7.5, 7.5, or 7, 7, okay, 7, 7, then here, 7.5. So the end bays, the gable ends are 7.5. Now, when I look at the elevation, this is north side, no, so south side. So this is the south side here. So this south side corresponds with this location. So on this location, or at this location, let me take an example. Between 5 and 6, or which also, okay, let me say between 5 and 6, right? So the exposure coefficient is so I calculated the area of this, okay, all over the area, total area of this. So the area of this, that's this place excluding the excluding the windows, all over the total blockage area. That gave me the exposure coefficient, and that was the exposure coefficient that was assigned. So if you look at, you have exposure coefficient different at this location, the end, because this span is 7.5, and then when you look at the elevation, we find out that the elevation, you have typical windows on this side. So but at the end B, because the span is different, sorry, okay, so you're seeing 7. So this is an outdated drawing. So the latest drawing, the spacing of this bay is actually 7.5. Okay, the spacing of this end bay is actually 7.5. So this was an outdated drawing. So this is 7.5, and the end here is also 7.5. That's the latest drawing from the architect. So we then used this to calculate the exposure coefficients for this region here and at the end, and then we did for this side, and then you assign it to the corresponding nodes. So if you look at, you have the exposure coefficient assigned to these nodes, and you have the exposure coefficient assigned to these other nodes in between. So that when STAAD is calculating the wind loads, after calculating the total wind force, that is applicable to each joint, it will multiply by the exposure coefficient to determine the loads on the joints. I hope this is clear enough. Thank you very much.